Law of superposition definition in geology. The law of superposition is a fundamental principle in geology that states that in any sequence of undisturbed sedimentary rocks or layered volcanic deposits, the youngest rocks or layers are found at the top, while the oldest rocks or layers are found at the bottom. This law was formulated by the Danish scientist Nicholas Steno in the 17th century and has since become a cornerstone principle in stratigraphy, the branch of geology concerned with the study of rock layers and layering. The concept behind the law of superposition stems from the processes of sedimentation and deposition, which occur over time as sediment particles settle out of water or air and accumulate to form layers. As new layers are added on top of older ones, the older layers become buried and compressed under the weight of the newer layers. Over millions of years, this process results in the formation of sedimentary rock layers with the oldest layers at the bottom and the youngest layers at the top. One of the key implications of the law of superposition is its utility in relative dating of rock layers. By examining the sequence of layers in a sedimentary rock sequence or stratigraphic column, geologists can determine the relative ages of the rocks, with deeper layers being older and shallower layers being younger. This allows geologists to construct a relative timeline of Earth's history and infer the relative timing of events such as mountain building, erosion, and the deposition of fossils. The law of superposition is also important in deciphering the Earth's geological history and understanding past environmental conditions. By analyzing the sequence of sedimentary rocks in different locations and correlating them with known geological events, scientists can reconstruct ancient environments and climates, track changes in sea level, and identify periods of tectonic activity. However, it's important to note that while the law of superposition provides valuable insights into relative dating and stratigraphic relationships, it does have limitations. In some cases, geological processes such as folding, faulting, or erosion can disturb the original sequence of rock layers, leading to situations where younger rocks may be found beneath older ones due to subsequent geological activity. Additionally, the law assumes that sedimentation occurs horizontally, which may not always be the case in environments characterized by tectonic activity or other geological forces. Overall, the law of superposition serves as a fundamental principle in geology, providing a framework for understanding the relative ages of rocks and reconstructing Earth's geological history. Despite its limitations, it remains a crucial tool for geologists seeking to unravel the mysteries of the Earth's past. Law of superposition application. The law of superposition finds widespread application across various fields within geology and related disciplines. Its utility extends beyond relative dating of rock layers to include a range of geological investigations, environmental studies, resource exploration, and even in forensic geology. Here are some key applications. Relative dating and stratigraphy. The primary application of the law of superposition is in relative dating of rock layers. Geologists use this principle to establish the sequence of events in Earth's history by determining the relative ages of rocks in different locations. By examining the succession of layers and their relative positions, scientists can construct stratigraphic columns and infer the relative timing of geological events such as volcanic eruptions, sediment deposition, and tectonic activity. Correlation of rock sequences. The law of superposition enables geologists to correlate rock sequences across different regions. By identifying similar sequences of layers with distinct characteristics, such as lithology, fossil content, or mineral composition, geologists can establish correlations between rock formations separated by great distances. This allows for the reconstruction of ancient environments and the tracking of geological events over vast regions. Paleoenvironmental reconstruction. Understanding past environmental conditions is essential for interpreting Earth's geological history and predicting future environmental changes. Geologists use the law of superposition to reconstruct ancient environments based on the sedimentary rocks and fossils preserved within them. By analyzing the characteristics of sedimentary deposits and the fossils they contain, scientists can infer past climates, sea levels, depositional environments, and ecological communities. Resource exploration. The law of superposition plays a crucial role in resource exploration, particularly in the search for minerals, oil, and natural gas. Geologists use stratigraphic principles, including superposition, to interpret subsurface geological structures and identify potential reservoirs or mineral deposits. By analyzing the distribution and characteristics of rock layers, geophysicists and petroleum geologists can pinpoint areas with high resource potential and guide exploration and drilling efforts. Geological hazard assessment. Understanding the geological history of an area is essential for assessing and mitigating geological hazards such as landslides, earthquakes, and volcanic eruptions. The law of superposition helps geologists reconstruct past geological events and identify areas prone to specific hazards based on the types of rocks and geological structures present. This information is crucial for land use planning, infrastructure development, and disaster preparedness efforts. Forensic geology. In forensic investigations, the law of superposition can aid in reconstructing events related to crimes or accidents involving geological materials. Forensic geologists analyze the sequence and distribution of sedimentary deposits, soil layers, and other geological evidence to establish timelines, reconstruct events, and provide expert testimony in legal proceedings. Overall, the law of superposition serves as a foundational principle in geology, providing a framework for understanding Earth's history, interpreting geological processes, and addressing practical challenges in various fields. Its applications extend beyond academic research to practical endeavors such as resource exploration, environmental management, and forensic investigations, highlighting its significance in both scientific inquiry and real-world applications. Law of superposition examples. The law of superposition, a fundamental principle in geology, finds numerous examples across the Earth's surface and throughout its history. These examples not only illustrate the application of this law but also provide valuable insights into the geological processes and events that have shaped our planet. Here are several examples. Grand Canyon, USA. One of the most iconic geological formations in the world, the Grand Canyon showcases the law of superposition in action. The sequence of sedimentary rocks exposed in the canyon walls represents millions of years of Earth's history. The youngest rocks, such as Kaibab limestone, are found at the top of the canyon walls, while the oldest rocks, including Vishnu schist and Zoroaster granite, are found at the bottom. This sequence provides a remarkable record of ancient environments, climates, and geological events. White Cliffs of Dover, UK. The White Cliffs of Dover, overlooking the English Channel, consist of layers of chalk deposited over millions of years. The law of superposition is evident in the vertical succession of these chalk layers, with the oldest layers at the base and the youngest layers at the top. Fossilized remains of marine organisms found within the chalk layers provide further evidence of past environments and sea levels. Sedimentary basins, such as the Permian Basin in Texas and the Williston Basin in North Dakota, are large depressions in the Earth's crust filled with layers of sedimentary rocks. The law of superposition is crucial for interpreting the stratigraphy and relative ages of rock layers within these basins. Geologists use this information to identify potential oil and gas reservoirs, as well as to reconstruct the geological history of the basin. Volcanic stratigraphy. The law of superposition also applies to volcanic deposits. For example, in areas with multiple volcanic eruptions over time, such as the Hawaiian Islands or the Cascade Range in the Pacific Northwest, the youngest volcanic layers are typically found on top of older layers. By studying the sequence of volcanic deposits and their associated features, geologists can reconstruct the eruptive history of a volcanic region and assess volcanic hazards. Fossil succession. Fossils provide crucial evidence for interpreting the relative ages of rock layers and demonstrating the law of superposition. For instance, in the fossil record, simpler organisms are typically found in older rocks, while more complex organisms appear in younger rocks. By examining the distribution of fossils in sedimentary sequences, paleontologists can establish relative timelines of evolutionary history and environmental change. River cuttings and road cuts. Road cuts and river cuttings often expose layers of sedimentary rocks, providing readily accessible examples of the law of superposition. Observing the sequence of rock layers in these exposures allows geologists and students to visualize the principle in action and gain a better understanding of how sedimentary deposits accumulate over time. These examples highlight the pervasive nature of the law of superposition and its relevance in understanding Earth's geological history, interpreting sedimentary sequences, and reconstructing past environments and events. Whether studying iconic geological formations or examining everyday exposures of rock layers, the principle of superposition remains a fundamental concept in geology.